Dear students, in this presentation, we will see one example on circular linked list application, or we can say we'll be making use of circular linked list to represent polynomial and to perform polynomial addition. The problem statement is like this: develop a program in C for the following operations on singly circular linked list with header nodes. In that, we'll be representing and evaluating the polynomial having three variables x, y, z, and find the sum of those two polynomials, that is polynomial addition, and support the program with the appropriate functions for each of the above operations. We'll be using mainly two things. One is to evaluate particular term by substituting the values for three variables x, y, z. Other one, addition of polynomials. In case of a three variable polynomial, each of the term is of this form. The coefficient part, like in this case, this is a coefficient part. The variable x, its coefficient. Variable y, its coefficient. Variable z, its coefficient. So coefficient x, its power, y, its power, z, its coefficient, like that. Then this is a circular linked list. Here I have taken this as an example. 6 is the coefficient, 2 is the power of 2, my x, 2 is the power of y, and 1 is the power of z. This is represented like this. Circular linked list is single circular linked list. The next node's address stored here, and the last node has the address of the first node. I'll be taking the first node itself as the header node. Single linked list or just header node. Here I'll be using a circular linked list. You can modify the program for the header linked list, circular header linked list. Let us take an example. This is a polynomial A and the other one is the polynomial B. This is polynomial A, this is polynomial B, and this is a sum. Here, one thing that we have to keep in mind that this particular x square, y square, z square will not be repeating anywhere in the polynomial. That is the assumption. This type of terms x square, y square, z square will not repeat in the polynomial. If the coefficient of x, coefficient of y, power of x, power of y, power of z are same in both of the terms, like polynomial 1 and polynomial 2, then only coefficients are added. In this case, x square, y square, z square is equal here in this term. So coefficient are added. 3 plus 2 is 5, and keeping these parts same. Like that you have to repeat for all the terms. Like I'm going to take this as my first a pointer. I'm going to use a pointer which is the start of the first polynomial and this is the beginning of the second polynomial. Okay, pointing to the first node. Here also is pointing to the first node. This is the polynomial 1 p1, let it be, and this is the polynomial p2. Okay, as is a circular, this node has the address of the next node, like that. Now I have to compare these terms x square, y square, z square of this with this term. As you can see, both are same. Then coefficient is copied to the new terms. After copying, no more terms available. That means no need to repeat till the last. Like this one, I did not compare the other one because what I have assumed that particular term exists only once in the expression, not more than that. 0 or 1 time, not more than that. That is why this particular matching x, y square coefficient available here. So I need not repeat till the end. I can stop. So that means this one and this one are added. So this is the answer. After that, I have to go to the next term, this one. Okay. So this term I can compare with the first one. Anyway, it is not matching. I'm going to compare with the second, it's not matching. So like that I have to repeat it till the last. As there is no terms here, this is the end. Even after repeating this also, the match is not found, so I have to copy this one to here. I have to copy the first term to the resultant. That means all these terms are considered traversed while editing, but this one is not matched. Once I started from the beginning of the P1, I have to repeat it till the end of the P1. When I reach the end of the P1, that means all the terms are considered. Now I have to look whether any unvisited nodes or the terms which is not added, that we need to copy to the resultant. I have to do that one. So again I have to start from this place only. I have to repeat as this is considered, this one is not considered, so I have to copy this one to the resultant. To make our task easy, in addition to the coefficient and exponent, I have to add one more field called flag field. Like in this case, the first term, right now all these are not visited. I'll be say assuming that the one more field, that is the flag field, as 0. That means not visited. That is the meaning. The first term of the first polynomial, first term of the second polynomial are same, so this is copied. Now I have to change this flag value to 1. So this will stop me in considering that particular term in the next visit. That's the thing. So as these are considered, I have to go to this place. This term is 0, okay, I have to consider. I have to start again from the first place of the second polynomial. This term and this term are considered for addition. It's done only if flag is 0. Here the flag is 1. I did not check this one. I can go to the next place, this one. This particular term of the first polynomial and this particular term of the second polynomial are considered for addition, though I can't add because the power exponent of x, y, z are not same. Y same, z same, but x is not same. So it's of no use. You can't add that one. That means I don't have any more terms here. So I have to copy the term of the first polynomial, second term of the first polynomial, first to the resultant. Now I have to change this flag value to 1. So this stops me in considering the term addition in the next stages. Here, this is considered, this also considered. As all the terms are considered, this, but answer is not proper. Because there is one left out term, I have to check that one. I have to start visiting all the nodes of the second column starting from the first one. As this flag is 1, I need not consider. This particular term flag is 0, so I have to copy directly to this one. So very simple algorithm, simple step. If the power of x, y, z are same, add the coefficient and copy. If not same, if not same, visit till the end. If there is no matching term, copy that first to the second, to the result. Like that you have to repeat till the end. For this program, we will be using evaluation of that polymer also. The power comes, the exponent comes, so math function is required. We are going to input the data and we may exit the program also. So stdio.h, math.h, stdlib.h are required. The node structure looks like this. This is a single term, the coefficient of the term, power of x, power of y, and power of z, and one more term that is required is, one more field that is required is the flag. Initially this flag value is 0. So this is power of x, exponent of x, exponent of y, and exponent of z, and this is the coefficient. This is how that a single term polynomial looks, and it is a linked list. We should have one more field, that is the address field, pointer field, which holds the address of the next term, next polynomial term. This address has to store. That means this is a pointer to the next node. That is why this field. So these are the members required. Coefficient of that term, power of x, power of y, power of z, and the flag field and the link field. This step I'll be aliasing. I'll be using a node which is of type this node. This is the alias name. So in my program I'll be using alias name, that is node. Now, as usual, like in case of a single linked list or anywhere, the first step is to get the node. To get that node, to like I'll be making use of this function for two purposes. One, to read data from the user. Other one, to copy that added terms to the result. So I'll be using insert term. Insert usually the rear end insertion. The ingredients or the information required. One is the coefficient, the x part, the y part exponent, z exponent of z, power of x, power of y, and power of z, and the linked list address. Okay, now this is a temporary pointer that is required. I'll be explaining while tracing this one. This is a new node that is created. Right now, I don't have any terms. For example, this node I have to create it 6x square and y square and z square. This is a term to be added. The linked list is null. Right now, I don't have any data in the linked list. It is a null one. So I have to create first node. Node is created. malloc or calloc I can use. So this is the first node of the linked list. One empty node is created having coefficient and exponent members. Exponent for x, y, z, and one more is a flag field. I have to copy the data now. First data to be copied is coefficient. In this case, 6 is the coefficient. It is copied. Then the next is x field, the coefficient of x, that is 2. I have to copy to this member. 2 is copied. Next, the power of y. The power of y is copied to the power x here. Similarly, z, that is also 2. The last field is set to 0 because not yet visited, that is a flag field. So these data have to feed into this newly created term. As the linked list is null, there is nothing in the header node. The first time header node is null. This itself is the temp node. The head itself is the temp node. This is newly created node and this is the head node. Here approach will call this node as the head node. Earlier its name is temp. I'll be changing that. I'll be using one more name, that is head. So that is this temp. So hope we'll see this part a little later. After that, after that, I have to make this as a linked list. Temp of link. There's a link field here. Temp of link. The temp of link is connected to the head. This is a linked list. Circular linked list. This becomes circular linked list. Now we'll be adding one more term, that is 3x power 0 y square and z square. This is a term to be added. We'll trace it again. One temporary variable current will be using. We'll see that while explaining the program. Using malloc create a node. Okay, I'll be creating the node. In this case, my linked list is not null. Head is not null. So coefficient is copied. X exponent is copied. Y exponent is copied. Z exponent is copied. Flag is set to 0. Okay, flag is set to 0. We'll see one more, that is the pointer field. Is head is null? No, this is not null. So this part is ignored in the next case. I will be marking this as current node. I will be marking this as the current node. Is current of link is head? Yes, current of link is head. That means no other node is there to visit. This is the only one node, or we have reached the end of the linked list. Is current of link is head? Yes. Not equal to head is false, so it is head. So what to do? Current of link is now connected to temp node. This is a newly created node, temp. Okay. The last step, temp of link. This is a temp node. Temp of link equal to head. This is the thing. I will explain this again with one more example, one more term. That new term to be added here is added means inserted is 4x power 1, y power 1 and z power 1. Okay. The first step is to create one node, assigning the values 4, 1, 1, 1 and flag is 0. We'll see this one. Is head is null? No, our linked list is not null. So I'll be using one current variable. This current is pointing to the current one. Current. This is a current variable. Is current of link is head? Current of link is not head. Not right now. This is not there. Okay. Then if it is not head, then what to do? Advance by one step. Current equal to current link. This is now current. This is a new current. Current node is advanced by one step. Okay. Again it is repeated. Current of link is it head? Yes, it is head. Now what to do? Current of link. Okay. Current of link is my new node. Okay. Done. Then temp of link equal to this one. This creates the linked list. I'll be erasing unnecessary things. This is a linked list. Not ordinary linked list, it is a circular linked list. It is a singly circular linked list. This is how to create new node. So now you have to feed the data, that is power of x, y, z, all those things you have to input. For that, we have to use a read function, read polynomial. We have to read x exponent, y exponent, z exponent, coefficient, and like whether you want to read that kind of for the repetition purpose. You're reading the coefficient of the term exponent of x, y, z. Then you have to call insert function. Initially head was null. I'm sending these information along with the head and that function returns. You can see the last statement here you can't see the return statement is there because it is returning node. So that I have to store it in head. If you want to repeat, just develop the program. Once that is over, you can call display function. Display function should come before this one. If head is not null, something is there. If head is null, it is empty. Otherwise, you have to display the coefficient first, then its exponent, y its exponent, letter z its exponent. Like in case of 3, some x square, y square, z square and minus 5 something is there. This is the case. So to display this sign properly, like minus 6 x square, y square and z square, I need to display this sign also. For that, plus d is used. This is the thing. This is a code for display routine. Now I have got first term in the first polynomial like x square, y square, z square, and the first term or one of the term in the second polynomial is also x square, y square and z square. I can perform addition only if these exponents are same. I have to compare exponent of the first one with the second one. Similarly, exponent of y with the first and second one, z exponent of both, like that or do. If all three are same, then only I can perform addition. For that, simple code can be used. Let h1 be the first polynomial term, h2 is the second polynomial term. So h1 power of x, h2 power of x are same and h1's power of y, h2 power of y is same and h1 power of z and h2 power of z. If all three are same, then only you say that are same, which can be used for addition. Otherwise return 0. Next, we'll see that addition of polynomial. We'll be adding two polynomial. The address of that is h1 and h2. We'll be using a temporary pointer. Let it be p1, p2, and say h3 or p3, anything. P1 is pointing to the first polynomial, P2 is pointing to the second one, and H3 is made null. You repeat this one. So do like this is the first polynomial 6x square y square and z square is the first polynomial and second polynomial is 3x square y square and z square. Right now, P1 is pointing to the first polynomial, P2 is pointing to the second polynomial that is H2. P1 is the first polynomial and P2 is the second polynomial. Right now, we are starting now P2 equal to H2. Okay. Second polynomial is pointed to P2. If P1 flag is not equal to, or P2 flag is not equal to 1, here one flag term is there that is 0 initially. That means we have not visited this particular node. If not equal to 1, that means if 0 only, start adding them. You can add only if comparison result is 1. So I have to compare by sending the polynomial 1 and the polynomial 2 terms to the compare function as we have seen earlier. Compare function. So it returns 1 if all the terms are, all the exponents are same, otherwise 0. That we are going to make use here. If that result is 1, that means terms are same. Then coefficient of the first one, coefficient of the second one are added. That is the result. Now you have to use insert function. We are going to add the new terms, but data is not from the keyword. Data generated code by addition like that. So coefficient is this one. Any one of the terms power x, power y, power z are sent. So to the resultant polynomial h3. You can use p2 power x, p2 power y, and p2 pure z. Why? Because in that case both terms, first one and second one are same. Once that is done, just come out because no need to consider other terms. Can save little time. Then after considering, for example, one more term is there, that is 3x, y and z. Now what to do? Right now we have processed this one. You have to mark these terms as one. Or to, if not same, what to do? You have to go to the next. That is why P2 equal to PTO link. Okay. After doing so, for example, in this case, 6x, y, z, and in the second polynomial, this is 6x square, y square, and z square. Let it be one more term here also. 3x, y square, and z square. Right now, P1 is pointing to the first one, P2 is pointing to the first term of the second polynomial. Are the same? No. So I reached to the end because no other term available. So what to do? If P1 initial 0, the flag is not changed. That means this term is not having any equivalent term in the other side. So you have to copy this to the result. When if flag is not equal to 1. If flag equal to 0, that means not yet visited. If flag is equal to 0, you copy the exponent of P1 power x of P1 power y of P2 P1 power z of P1. All three informations are copied to the insert function. That is, we are updating H3. Set flag equal to 1 to avoid next time visit. Okay. Having done this, we completed these terms. We have to go to the next one. For that, this is the thing. P1 equal to P1 of link. So you repeat this process once you reach the header node. That is, P1 is not equal to head. As we are pointing the last node in the first, which is not equal to head, then only you repeat it. So that means all these terms are now considered results added here. You can see here this one matching same, right? This one not matching. So what to do? You reach the end. That means you have to copy this to the resultant. That is told here. visit visit unvisited term, complete that traversing by visiting the unvisited. How do you say that it is unvisited if flag value is equal to 0? If it is not equal to 1. If it is not visited, copy the coefficient part, exponent of x, exponent of y, and exponent of z to the resultant. Set flag equal to 1. Like that you have to repeat it. So if one term is over, go to the next term. This particular code is required if at all any term left out in the second column. I will show it again. In this case, this one done, this one not there. So you have to copy. This one is copied. So after copying all the things, still one more term is left. That is in the P2. That you have to add it. That is a code given here. Code given here. This is a thing. So display the result, update it H3 that can be returned. The next part of the question is to evaluate. Particular term is given, you have to evaluate it. So you'll be inputting the value for x, y, z. If head is not null, what to do? You have to raise that power. Simple function only. You multiply like a term is 6 square, y square, and z if given. X value is 2, y value is 2, and z value is 5. The answer will be like result right now it is 0, 6 coefficient, okay, multiplied by power of x value let it be 2, 2 power 2 that is 4, then y value is also 2, 2 square is 4, z value is 5. This is the answer. 6 into 4 into 4 into 5 is the answer. After evaluating, go to the next term, temp equal to temp of link. So you repeat this if it is not matched. This is the program. Main part, we need two inputs h1 and h2 and for the result h3. The operation that we are going to perform are evaluate, addition, then exit. Choice can be read. So you read that first polynomial h1 equal to read poly of h1. Then evaluate it. In the second case, you read h1 and h2, add them h1 and h2. Break. Read polynomial 1, read polynomial 2, add them. Break. So this is the lab program, that is polynomial addition when there are more than one variables. Thank you.